Welcome back to Chem Sleeping Lab, episode 12. Tonight we will talk about a very small heat source. So small you cannot see flame, but it can still start a fire. Static electricity. What is static electricity? So everything is made of atoms. Atoms have electrons, very small negative charges that can move from one surface to another when two surfaces touch and then separate. When you take off a sweater, fabric rubs fabric. Electrons move. When you pour a liquid quickly through a plastic funnel, liquid rubs plastic. Electrons move. This is called triple electric charging. Usually, this charge flows away quickly through air or through your body to the ground, and you feel nothing. But in dry air, charge stays longer. Air with more humidity has more water molecules. And water helps carry charge away. In winter or in an air-conditioned lab, air is dry. Humidity is low. Charge stays on you, on clothes or on plastic. So you become like a small battery. You do not feel it until you touch something metal, like a doorknob or a metal shelf. Then electrons rush quickly from you to the metal or from metal to you. That rush is a spark. You hear a tiny snap and feel a little shock. That spark is very short, less than a millisecond, and has very small energy. For you, it is just a little surprise. But for flammable vapor, that tiny energy may be enough. In episode 3, we talked about fire triangle, fuel, oxygen, and heat. For vapor, fuel is the vapor mixed with air. For vapor to ignite, you need to give it a minimum amount of energy. We call it minimum ignition energy, or MIE. Different fuels need different MIE, and many common flammable vapors have very low MIE, which means they need very little energy to ignite. Dust clouds also have low MIE, especially fine metal dusts and some organic dusts. That is why static is dangerous where there is a flammable vapor or combustible dust cloud nearby. Where does static happen in a lab or workshop? 1. Pouring flammable liquid from one container to another. 2. Flowing liquid through a pipe or hose quickly. 3. Walking across a floor with non-conductive shoes, then touching a metal container with vapor around it. 4. Wearing synthetic clothes like polyester fleece, which can charge easily in a place with solvent vapor. 5. Using plastic containers that are not conductive. Plastic holds charge. You cannot see vapor. You cannot see charge. But the combination can make a spark in a place where vapor is present. How do we control static? 4 main ways. 1. Grounding. Grounding means connecting something to the earth, to the ground, through a wire. The earth is very big. It can take a lot of charge. 2. Bounding. Bounding means connecting two conductive objects together with a wire, so they have the same electrical potential. No potential differences, no spark between them. 3. Humidity in materials. Increasing humidity to around 40 to 60% reduces static buildup because moist air is more conductive. Using conductive or static dissipative materials instead of using insulating plastic helps. 4. Slow handling. Pour slowly. Avoid splashing and free fall. Pour close to surface, down the side, with low height. There is also anti-static additives and anti-static sprays for floors and clothes. But for a small lab, grounding, bounding, humidity, and slow handling are the main controls. A simple check. Before you pour a flammable solvent, touch a grounded metal object first with your hand, like a grounded metal shelf or metal part of a fume hood, just to discharge yourself. You may not feel a spark, but you're letting charge go safely, not through vapor. In SDS Section 7, Handling and Storage, you will often see a sentence: take precautionary measures against static discharge. Ground and bound container and receiving equipment. Now you know what that means. Let us make calm habits for static, for every day, and for the lab. At home, when air is dry, you get shocks from doorknobs. You can increase humidity with a small humidifier, or touch a metal object with a key first, so spark goes to the key, not your fingertip. Less painful. In the lab or workshop, handling flammable liquids, wear cotton, closed shoes, not synthetic fleece, not wool that charges easily. Use metal containers and metal funnels for flammable liquids when possible, and ground and bound them. Pour slowly down the side, low height, in a fume hood with ventilation that removes vapor. Before pouring, touch grounded metal to discharge yourself, and keep containers closed when not in use. Remember, static itself is not dangerous to you. It is dangerous because it can be the heat side of the fire triangle when fuel, vapor, and oxygen are already there. Risk equals hazard times exposure. Here, hazard is flammable vapor. Exposure is vapor cloud plus a spark. Grounding, bounding, and ventilation are your safeguards to reduce exposure to both. Let us review for tonight. Static electricity is electrons moving from one surface to another when they touch and separate. We control static by grounding, connecting to earth, bounding, connecting continues together, increasing humidity, using conductive materials like metal, and pouring slowly. That is all for episode 12.